Today we will continue subprograms, parameter passing methods. What are the different methods of passing the parameters to subprograms? We were seeing. So last class we have discussed about this pass by value, pass by result, pass by value result, and the remaining two also we'll probably discuss today, and we'll see from different programming languages perspective how this classification is available. Okay, so the function which is calling is said to be the caller, right? Yes. And the function who is being called is said to be the callee. So when you're passing the parameters, the actual parameters for these formal parameters, okay, during the function call, we say it is in mode operation. Okay. And if the callee is returning the values to the caller, we say it is out mode operation. If we have both the provisions available, that is passing the parameters to the formal, and then getting the value or the values from the callee being returned. If we have two-way communication, then we say it is in-out mode. Okay. If only from calling the communication is happening, messages or parameters are being passed, then we say in mode operation, in mode communication. If the callee is sending some results or some values or some messages, I said, okay. So because this is a different kind of terminology that is being used across different books. Some say message passing mechanism, some say parameter passing mechanism, and all, right? So if the message is being sent from the callee to the caller, we say out mode operation. If we have both the provisions, that is caller can send and callee can send, then we say it is in-out mode operation. Okay, in-out, when you have both. So we have discussed about these three kinds in the last class. If you have any doubts, you can raise so that I can probably address the same and then go ahead with the remaining two as well. So in pass by value, what is happening? The value of the actual parameters is used to initialize the corresponding formal parameters. So how it is being implemented? Normally it is being implemented by copying. So the extra overhead that is needed is storage and copy, right? So you have to copy the values of actual parameters and they should be stored in the callee as well. Okay. So which is a cost effective kind of thing. Pass by result, out mode operation. When callee is sending the messages, when a parameter is passed by result, no value is transmitted to the subprogram. The corresponding formal parameter acts as a local variable. Its value is transmitted to caller's actual parameter when control is returned to the caller. It requires extra storage, location, and copy operation. Okay, so copy and storage here as well is required, right? So the potential problem that you may encounter here is when the value is being copied, that can be rather reflected at the callee as well, when that is being changed at the caller side. That is one of the side effects, right? Pass by value result. A combination of both pass by value and pass by result, where the caller can send some messages and callee also can send some messages to caller. Right. So if you look at here again, how it going to be implemented is by again copy storage kind of thing. So extra overhead for the this copy and storage is a cost of fair thing, and disadvantages which you probably have discussed in both of them will be associated with this kind. Now coming to pass by reference. Okay, so this we will discuss now. So pass by reference basically can be implemented in C++ with the help of reference variables. I'll give you the example of C++ in order to explain or make you understand the same. I'll take one example of swap operation. Let us take swap operation. So how do you represent the reference variable with the help of ampersand, right? Ampersand x, comma, int ampersand y. Okay. Now let us take one temporary variable. You want to swap x and y. So you say x equal to temp, sorry, temp equal to x equal to y, and y equal to temp. Okay. So what is happening here? The x value is temporarily held in temporary variable. Then y is placed in x. So x got y, and in temp what value you had? X, that you are placing in y. So x and y got interchanged. Right now, we will demonstrate the same with the help of main function. Okay. So let us take two variables, a comma b, and let us say you are reading this or accepting these values. Enter AB values, C in AB. Now after this I am continuing here. So now you want to display the values of A and B before you call the swap function. Before swap, A equal to A and B equal to B. Now let us say you are calling the swap function. So swap function is being called here. We are passing the actual parameters. Now we wanted to display the values after being called. So after swap function being called, you want to display a value and b value, right? Now let us demonstrate this. Fine. So I'll first demonstrate this, then I'll come back to the mechanism. Right. So the execution always starts from main, right? Now you have two variables a comma b. So for a, memory will be allocated before swap a equal to 10 and b equal to 20 will be displayed. Okay, good. Now you are calling swap function. When you are calling swap function, what is that you are passing? You are passing actual parameters. These are said to be what? Actual parameters, right? Fine. So these are being passed. Now what happens in reference concept? These are the reference variables. How do you identify that they are reference variables? If a variable is preceded with an ampersand, you can see this variable at the time of declaration preceded with ampersand. This is also. So both of them are reference variable. And they are said to be what? Formal variables also, right? variables which are defined inside the function definition. Now these are reference also. Let's say these are reference variables. Okay. Now for reference variables, what happens? Memory will not be allocated. Rather, they will act as an alias name to the actual variables. So it means X will act as an alias name to A. So during the execution of this function, only during the execution, because these are local to this function. Okay, these X and Y are local to this function. So during the execution only you can access these X and Y, because the scope of X and Y is restricted to this function only. So now this X will act as an alias name to A, because we are passing A to X. The first actual parameter will be initialized to the first formal parameter. So the actual parameters when you pass, they should be passed in corresponding to the formal parameters. So now X will act as an alias name to A during the execution of the function. Okay, and Y will act as an alias name to B during the execution. Okay, so in function, when I am saying X, it is nothing but A, right? So by being in this function, you are able to access the memory of main. Okay, this is all possible. This is called indirect way of accessing. See, this memory was actually allocated for A when you have declared A, but then this memory can as well be being accessed here in this function through another name. So this way of accessing is said to be what? Indirect way of accessing, right? Indirect way of accessing. Now, so when I say in temp, for temp memory will be allocated, where temp memory will be allocated inside the function, okay? Because it's a local to this function, it's a local variable, and the scope of this function variable is within this particular function. Next statement you have is temp equal to X. In temp, what is that place? X. What is X actually? 10, right? Because it is accessing, this memory which is being basically allocated for A, right? X equal to Y, when you say Y value will be placed in X, Y value is 20, which is being placed in X. Then you say Y equal to temp, temp value will be placed in Y. Where is the temp value? Temp value is this 10, will be placed in Y. Y is nothing but it is this, right? So here. Alright, so after this you come out of this function. So now another statement that you have is to display after swap. As per the mechanism that we have discussed in the last class, that when you call a function, this is a function call. What is this said to be? Function call, right? This is a function call. When you call a function, what happens? First the values are being passed. The actual parameters or the actual values will be passed or initialized to the formal parameters correspondingly. Then the control is transferred here. Then the execution will take place. Once the execution is done, the control will be transferred back to the caller, right? This is the caller, this is the Kali, right? This is caller. This is the caller, right? Now what is happening here? After you return from the Kali to the caller, you are displaying another, you are displaying some statement using this here. What is that you are saying? After swap A equal to, what will be displayed here? In A, what is the value you have now? 20, right? It's not 10. And B equal to what? 10. So it means you can see before swap, A value was 10 and B value was 20. After you have called swap, you can see A and B got interchanged. And this has been done through a function. So this function is accessing these memories, right? This memory is local to this main. You can see AB are local variables to main. So AB can be accessed only within main. Okay. Similarly, X and Y are local to this function. They can be accessible only within this function. Their scope is limited to this function. But being in its scope, it is able to access the other scope, memories are variables. This is what the beauty of reference concept, right? This is as well can be implemented with the help of pointers that you see it in C, right? In C, we can implement it with the help of pointers, right? In C++, we can implement this concept using reference variables as well using pointers. Okay, both are being made available. In Java, you have reference concept available, similar to this. So this way, you can probably access the indirect way, indirectly the variables, right? So indirect way of accessing the variables, you can do it with the help of references. I hope this is clear to all of you. Now we'll see the uh, pros and cons of the path by reference. Pass and access path, right? Here you can see the variables x and y, they are just acting as an alias name to this a and b. Means what? These memories, which are basically being created for a and b, are now being shared with x and y. During this function call, they can be accessible. It means these memory locations are shared to this function, and this function is accessing these memories with the help of these variables, right? So pass by sharing also, sometimes we call it as this pass by reference. Okay, so passing the process is efficient. No copying, no duplicated storage. Are you copying these values? A value, is it being copied here in the formal? B value, is it being copied in the no? And for x and y, do you have some storage required? No. X and y, for x and y, no memory. The duplicated storage is not required. No copying is required. See, x and y, they don't require any memory, and they don't need any copy from it. Rather, they are just acting as an alias name to the original memories. Yes or no? So in pass by value, we have seen copying of this actual parameters to the formal is going to be done. In such case, formal parameters also need some storage. So storage and copying was required. But now in this case, you can see there is no copying and no duplicated storage, because these values are not duplicated at any other place, rather, right? So they are just acting as an alias name to these variables, and they are able to access that memory and change that memory values as well, right? So this is all possible with the help of pass by reference, right? So disadvantages, like it is slower access, right? Compared to pass by value, they are slower to access. Potential for unwanted side effects. Sometimes, okay, unwanted aliases. If these aliases will be created and will be available, and if you have some other function where again you want some reference variables to point to this, and those reference variables also will be made as aliases to this, because you can have any number of aliases to the same memory. So unwanted aliases probably sometimes, and this is one of the side effects. Otherwise, it is quite helpful mechanism to access the memory indirectly. You can access the memory indirectly using this pass by reference concept, which is available in C++ and as well Java, right? We'll probably see with respect to programming language in the next coming slide. I hope this mechanism is clear to all of you. So shall we move on to the next slide? Yeah, next one is pass by name. Okay. One thing I would like to tell you, that pass by reference also comes under in-out mode or not? Yes, because see, the values which are being taken by x and y, after they are changing, they are reflecting it on the memory of the actual parameters that you have passed to the formal, rather, right? So see, the message is going from the caller to callee, that is 10 and 20 is going, and what is that callee is sending as a message? It is sending 20 and 10 for AB, right? So it is two-way communication. This pass by reference is also two-way communication. It is also two-way communication in out mode. Okay, because the messages are being passed from caller to callee, right? It is of course implicitly. This is all happening implicitly, not explicitly. In pass by value result, you may see that that is being done explicitly, but here you can see it is implicitly, but then the mechanism is of course in out mode only, right? Yeah, next is pass by name. Shall I erase this? Yeah, pass by name. This is another kind of implementing the subprogram using parameter passing method or mechanism. So in this, what happens? The textual substitution happens. Fine. So when you pass some parameters, the parameters will be substituted directly. Fine. Then and there, wherever you are calling, it means the control need not to take from caller to callee, and after the processing at the callee is done, the control need not to be returned. Fine. I'll give you an example which you have already worked with in C++. Formals are bound to an access method at the time of the call, but actual binding to a value or address takes place at the time of reference or assignment, allows flexibility in light binding. So binding happens in the runtime. So that's the reason why we say it is late binding. I'll give you here one example. You may have worked with macro functions, right? You may have seen macro functions in C or C++. And how do you define macro functions? For example, you have, let us say, square of a number you want to do. Hash define square within the parentheses. You're mentioning the parameters, as it will be the form of parameters, and the operations followed by the same x into x. Okay. How do you find the square of a number? X into x. Okay, with asterisk. Right? So x into x. Now, if I have to implement this function, how do I implement? Let us take C++ or C. Any example is okay. So let us take C++ example. I want to find the square of. You can pass a parameter or a value, no issue. Let us set a. You are saying a equal to 2. Now, square of a, you are saying we call this, right? Square of a, right? So when you do this, I'm first giving you the example from the language point of view, which you know it. Then I am taking it onto the concept, right? That will help you to understand little easy, right? So square of it. So this is the macro function. These are said to be macro functions, which you generally define at the, where do you define? Immediately after header file or before header file. Before you start writing any functions, you do that, right? Macro function. Macro functions are defined at the top, right? Hash define is a square of x followed by a space followed by the code x into x. Now in the main function, when I call the square, what happens is the code will be substituted. And at the the place at which this function is called, at that place the code will be substituted. Okay, it is not like the control will be taken from, this is the caller, right? This is the callee. So control taking the control from caller to callee, and then after processing it, then control will be returned from callee to caller. This is not right going to be done. Rather, in case of this macro functions, what happens is wherever you call, you know, there the code will be substituted in place of the call. Fine. So in place of this call, what is the code you have? X into X. But for X, what is that you have passed A? So it means A into A will be substituted here. Okay. So control is not being taken there, and control is not returned from there, and all kind of stuff. So in this extra overhead that probably needed for taking the control and returning will be rescued from being invested. But then, of course, we have some side effects as well that probably we'll see when you study C++. There it was corrected with inline functions. You may have studied inline functions also, right? Rather. That anyway, the secondary thing. But here, I just wanted to bring you how the pass by name can be implemented. So just focus on pass by name here. So what is happening? Textual substitution. The code will be just simply copied. The place at which you are calling, right? The place at which you call, the code will be substituted. So these formals, these are the formals, right? So formals are bound to an access at the time of the call. But at the time of the call, only then these formals, will be changed. And when the call is made, you are passing the actual, right? So that actual will be binded to the formal with the substituted text at the time of execution. So this is all happening during the execution. Okay, this is all happening during the execution. So it means formal binding with the actual will not be done before runtime, whereas in other cases binding will be taking place before execution itself. Here, no binding. So it will wait until the execution, right? So when formal binding is not at all there, it will wait until the execution. Once the execution comes, means when that particular statement comes for execution, the textual substitution first happens, then automatically the formal binding to that respective, these are the formal parameters, right? So when textual substitution happens, it could be X into X, but then formal will be replaced with the actual that you have passed. So automatically the code will be at the time of execution generated at this particular basis A into A. So if A value is 2, then 2 into 2 you will get 4, right? That's the point. So this is how the pass by name is going to be implemented. With certain corrections, some languages have adopted this, and some languages will probably have overcome with the side effects that are available with it. So this is available in both C and C++, of course, right? But there is a small side effect. Can you identify the side effect here? I will mention, right? See, if I am passing some expression instead of a variable, basically an actual parameter. The actual parameters can be a value. It can be a parameter of which value being read before, or it could be sometimes expressions also, right? So if I have, let us say some expression, if I have some expression like, let us say A plus plus, A plus plus, okay? So what do you mean by A plus plus is a post increment. So in case of post increment, what happens? The value will be used first, then incrementation will take place. So what happens as per the mechanism behind the macro function, the textual substitution. Textual substitution when happens, so what do you get here? What do you get? You will get A plus plus into a plus plus. Yes or no? Fine. So now what happens? This is all going to be done during the runtime, right? Binding of the actual with the formal is being done during the runtime, and textual substitution is being happened during the runtime. First textual substitution, then formal binding. Both going to done at the runtime. So it is done. So what did you get now? A plus plus into A plus plus. Now when this is being evaluated, as per the rule, how is it going to be evaluated? Since this is a post increment, this is a post increment. What happens first? A value will be used. What is the A value here? 2 you are taking. So it will be 2 here. And then what happens? A value will be now incremented. So A value which was 2 before, now after this execution, this is a post increment you have. So A becomes 3 now, right? So into, when you come to this particular statement, right? When you come to this particular operation, because basically here you can see multiple operations, right? You have into, but then you have post increment here and post increment. These are said to be what? Post increment unary operators. They will be given higher precedence. They will be given higher precedence. So higher precedence operators will be evaluated first. It means, and when you have equal precedence operators like this and this, both are having equal precedence. So which one will be evaluated? Obviously, left to right you go. So A plus plus will be evaluated first. So what is happening here now? A plus plus. So A value got 2, and then A is incremented. A value is 3 now, right? Again, you have unary increment, unary operator. So what happens? This is going to be implemented. When this is implemented, what happens? First, the value being used here, that is 3, and then A value will be incremented. Now the into will take place. When into will take place, what is the result you are going to get? You are going to get 6. 6, is it a square of a number? No, 6 is not a square of a number. Actually, you wanted to find the square of a number with the help of the code. Code is correct. But then if you're passing some expressions, right, then it is not working, right? So this is one of the side effects that you find it in C and C++ when this mechanism was implemented with macro function. But then it was rectified in C++ with the help of inline functions, right? So you may have heard about inline functions. So in inline function, what happens? The textual substitution doesn't happen. The mechanism will be as like how the normal function, that is taking the control and returning the control. Sorry. Evaluation will be done before the execution. I just give you the example for the same, so you'll be more clear about it. Okay, so in inline functions, and probably the return type you can have as void if you want. It is not. It is returning value, right? So you can have integer value it is returning. So inline int space int space square of int x, return x into x. So now this inline function actually was introduced in C++ by overcoming the side effect that we have just discussed, which is associated with this macro function. The motive behind the inline function is also very similar to that of textual substitution. So what happens here is code will be substituted, fine. But then what happens is, if you pass some expressions, expression will be evaluated then substituted. That is the difference from the macro function. In macro function, what was happening? If you pass any expression as a parameter, that expression also will be as it is substituted in the code. Yes or no? But now when you, if I use the square function, small square is an inline function, right? So if I am calling same a plus plus for it, okay, what do I get? square of a plus plus, if I say, then what do I get here? Provided a value is 2, let us say. Okay. So what happens here? Same substitution of text will happen. Means code, instead of having the control being sent there and the control be written, like how macro functions, textual substitution will take place. It means x into x will be done here. But then the parameter, fine, actual parameter when being binded with the formal, okay, it is not substituted as it is in the code. Instead, if it is an expression, that will be evaluated first. When it is evaluated, and if it is a post increment, what happens? A should be used in it, right? So it means a into a will take place, then a plus plus will be done. So what do you get? You will get 4 only. Means square of a number you get, right? If you have plus plus a in place of this, then pre-increment first has to happen, then the value should be used, right? So a value is 2, then plus a means it will be 3, and then here it will be substituted, then you get 3 into 3, that will be 9. 9 is also a square of a number, so no issue, right? So this kind of side effect which was available also with this particular macro function found in both C and C++ was corrected in C++ with the help of inline functions. Okay, now both comes under the same pass by name kind of thing, right? So in pass by name, what do you do? The textual substitution will happen. Okay, so formal binding is going to take place at the runtime. Okay, I hope this is clear to all of you. If you have any doubts, you can please raise here. So I think it is clear for all of you now. Shall I erase this? Yeah, I'm erasing this. Okay, now implementing the parameter passing methods, right? In most languages, parameter communication takes place through the runtime stack, right? So there is a stack, as I said, at the beginning of the classes, right? Initial classes. Now memory has been divided into 3 parts. One part to store instruction, another part to store data, another part is used to store the stack. For every user, when he is submitting his request, a stack memory, a part of the stack memory will be allocated and stack operation will be performed. Like we have seen, what are the different kind of applications of the stack, like infix to prefix of postfix conversion, or evaluation of prefix of postfix, recursion or function call, and these all things needed by any programmer at any point of time all the time. So stack is very much required, and functions are also being implemented through the runtime stack. Pass by reference are the simplest to implement. Only an address is placed in the stack. So you don't need copy, storage, and all kind of thing, right? In pass by reference. So only thing you need to do is just to maintain a reference. That's it. But fatal error can occur with pass by reference and pass by value reset. A formal parameter corresponding to a constant can mistakenly be changed. So sometimes the value which is being returned to the caller from the callee gets changed, and there is a possibility that may be reflected at the caller. But in programming languages, what they do is they restrict it from being copied in the other way around. It means when it is once taken from the callee, that will be restricted from its scope. So this kind of disadvantage, when early days, when the concepts were being evolved, these are some of the issues that are being discussed, and then they were being rectified with the with program language designers, and they have adopted in order to ensure that this side effects will never encounter, right? So if you see from different programming language perspective, Fortran language, if you take, always use the in-out semantic model. We have seen now call by value, pass by value is a in mode, right? Pass by result is a out mode, we said, right? Pass by value is in out mode. Pass by reference is in out mode, right? So like that. Pass by name also we said, right? So these are all some of the modes which we have discussed, rather, right? Pass by name is also in out mode, right? So Fortran always used the in-out semantic models. Before 77, Fortran 77, pass by reference was being used, and after that, scalar variables are often passed by value result. In C, you find pass by value, and pass by reference is achieved by using pointers. Okay, in C, how is that pass by reference is going to be implemented with the help of pointers. If you want me to give an example, I'll give you an example of the swap. Here you can see. Okay, we'll take one example of swap in C or call by reference using pointers. Okay, so let me explain here. How do we declare a pointer? With asterisk, right? Asterisk x int asterisk y. Okay, you have a temporary variable which is local to this function, and equal to asterisk x equal to asterisk y, then asterisk y equal to 10. So in main function, you can have two variables similar to the previous example, a comma b. So a values and b values have been read. Let us say initially I'll take the values as a as 10 and b as 20. Before swap, a equal to a and b equal to b. Now I call the swap function. How do I call when I have the pointers? I need to pass the addresses, right? Ampersand a comma ampersand b. Now I say cout after swap, right? A equal, as I told you, right? Pointers will, for pointers, memory will be allocated to hold the address of 1 byte, hardly 2 bytes in many of the programming languages, right? So now A address is 100, which is being passed to X. So X pointer is holding the address of A. It means X can access this memory, right? Y, asterisk Y. This is another pointer for which you are passing the address of B. So address of B is 200, so 200 is passed to Y. Now you can see there is a temporary variable. So for temporary variable, memory will be allocated. You are saying temp equal asterisk x. What is that happen here? Asterisk x means value 8, right? Value 8. Value 8 address held by x. What is that? 10, right? So that 10 will be placed in temp. Then asterisk x equal asterisk y means what? Asterisk y means value 8. Asterisk is an indirection operator, which is when being used at the right hand side, it will access the value. If it is being used on the left hand side, it will access the memory. Okay, so asterisk y means here value at y, which is nothing but 20, and this will be placed at asterisk x means x pointed memory. So here, right now, asterisk y equal to temp, when you say temp value, that is 10, will be placed in y pointed memory. That is this, right? You can see here in this case also the swapping is done, right? So the pointers also, by being in one scope, the scope of x and y is limited to this particular function. Okay, but then they are able to access the memory of the other scope. This is possible with the help of pointers, right? By being in one scope, it can access the other scope memories, right? So after this, when I print, what is it after swap? After swap, a equal to, what is that a value I got? Not 20. B value I got as 10, right? I got it as 10. So you can see that the values are being swapped here as well. Of reference before we have seen, yes or no? Pass by name. Under pass by name, an example which we have taken to see. Pass by reference. Sorry, pass by reference. We have used call by reference. So of C++, right? Using reference variable. Is it not very similar to that? But then reference is better than this rather, I can say, right? In reference, no storage, no copy is required. Here, For X and Y, some storage is required. For pointers, also memory required, and it holds the address, and then it accesses the memory indirectly, right? So sometimes you may result with some kind of what you call segmentation fault and all kind of thing. Errors. Otherwise, it's fine. Fine. So this call by reference mechanism in C, how it is being implemented in this fashion, right? Call by reference is implemented in C in this fashion. Got it? The same mechanism when being implemented in C++, in C++ also this is available. We say it is call by address. Okay. And if you are implementing it with the help of references, then we say it is call by reference. So call by references can be implemented in C++ with two mechanisms. One is with pointer, another one is with reference. Whereas in C, you can implement this with the help of pointers only. Got it? I hope this is clear, all of you. Next is in C++, a special pointer type called reference type being used for pass by reference. So in C++, whatever is there in C, it is as it is there in C++. So C is C++ is an increment of C. So what is there in C? As it is there. So it means call by value, this pass by value, pass by reference with pointers, both are there. But in addition to that, in C++ we have, with the help of references also, you can implement this pass by reference mechanism. In Java, all parameters are passed using pass by value only. When you have objects, they will be implemented with the help of pass by reference. Okay. This is what about the different programming languages, how they are implementing this, parameter passing methods, right? The parameter passing methods of major other languages like ADA. Three semantic modes of parameter transmission will be used in ADA: in mode, out mode, in out mode. Okay. In is the default mode, of course. Form parameters declared out can be assigned but not referenced. Those declared in can be referenced but not assigned. In out parameters can be referenced and assigned. See, this is being adopted by ADA by overcoming the difficulties, the problems which we have discussed available and associated with the in-out mode. C hash language, if you see, the default method of parameter passing is pass by value. Then you have pass by reference is specified by receiving both a formal parameter and its actual parameter. We have reference kind of keyword available in C hash, very similar to that of ampersand, like in C++. So PHP is very similar to C hash. PHP is a hypertext preprocessor language which is being used for web scripting and all. And Perl is also practical extraction reporting language, also being used for web scripting. All actual parameters are implicitly placed in a predefined array name. Okay, in array name, the value will be placed. Okay, type checking is also available. Like type checking must be required, right? When you're passing the actual parameter, whether you're passing the correct type to the corresponding type or not, right? That is considered very importantly for reliability. Fortran 77 and versional C, they have none, but the user has to take care of the same. Pascal, Fortran 90, Java and ADA, it is always required. ANSYS, C++, choice is made by the users. User must have to do that by specifying the prototype before. The designer or the programmer will notify the users to use this type checking to be taken care while being implemented, right? Relatively new languages like Perl, JavaScript and PHP do not require type checking. Okay, so this is all about from my side for today's class. So I hope this is clear to all of you. If you have any doubts, you can raise. Otherwise, we can stop our class here. Okay.